Okay, we are solving sine of 1/3 x equals 1/2 on the interval from 0 to 2 pi. Now, if you have an equation where your variable is being multiplied or divided by a value, the first thing you want to do is solve it as if there was nothing there. So instead of 1/3 x, let's just solve it as sine of x equals 1/2. So because that's positive, remember all students take calculus. Sine is positive in quadrants 1 and 2. So I'm going to draw my triangles. Sine has a ratio of y over r. So each hypotenuse is 2. Each height is 1. If you were to use the Pythagorean theorem, you're going to find that the remaining leg is a square root of 3. So this is a special right triangle with the reference angles being 30 degrees. The reason the reference angles are 30 degrees, remember the smallest angle has to be opposite the shortest leg. So in order to find my solutions, we're going to go ahead and rotate from standard position to each hypotenuse. So we rotate to the first hypotenuse, that's 30 degrees. So I'm going to put pi over 6. So I'm going to start over again, standard position to the hypotenuse. Okay. Now I've rotated 150 degrees to have a reference angle of 30 degrees. So that is 5 pi over 6. Now, if there's any operation being applied to your variable, this is an exception where you have to add 2 pi n or pi n depending on your trig function. Because we're solving for sine, we're going to be adding 2 pi n to each of these. And of course, you don't want to forget to state that n is an integer. Now, normally this would be the end of it. We'd have x equals our solutions and we'd be done. But we didn't solve for x, we solved for x over 3. This is where that operation comes back. So now I want to make sure to isolate this variable. So we're dividing by 3. I'm going to go ahead and simply multiply by 3. So this is going to give me x is equal to 3 pi over 6 is going to be pi over 2 plus 3 times 2 pi n is a 6 pi n. And then for the other one here, x is equal to, that would be 15 pi over 6. So 5 pi over 2 is what it would simplify to, plus 6 pi n. Now you're looking for as many solutions as you can get on this interval right here. So for this first part, this first expression, I'm going to go ahead and combine those. Let's say pi over 2 plus 6 pi n over 1. Well, our common denominator would be 2. So I'm going to end up getting pi over 2 plus a 12 pi n divided by 2. So I'm going to get my solutions by using pi plus a 12 pi n over 2. Okay. And now I just want to go ahead and start putting in as many values for n as I can. Let's start with n equals 0. So if n equals 0, I've got pi plus 12 pi times 0 divided by 2. Well, anything times 0 disappears, so I have a solution of pi over 2. Now let's go to n equals 1. Now, you might be wondering, how far do I have to do this? How many values of n do I have to plug in? Well, you're going to continue to find solutions until you find a solution that's outside of your interval. So when we get something bigger than 2 pi, that's when we can stop. So if n equals 1, pi plus 12 pi times 1 over 2. Well, pi plus 12 pi, this is going to give me 13 pi over 2. Now, this is a solution. This is going to make the equation correct. But let's rewrite it as a mixed number. 2 will go into 13 6 times with a remainder of 1. So this is equivalent to 6 1/2 pi. Remember what I said a moment ago, You're going to continue to find answers until you start to find those outside the interval. 6 1/2 pi, while it still is a solution, is well outside that interval. So the only solution I'm getting out of the first one is pi over 2. Now we want to turn our attention to the other one. Now, I know what's about to happen, so I'm only going to go ahead and start to plug in values of n. So let's start again with n equals 0. So I've got 5 pi over 2 plus 6 pi times 0. Well, anything again times 0 disappears. So 5 pi over 2 is another solution. But 5 pi over 2 is 2 1/2 pi, just like 13 pi over 2, while a solution, it is outside the interval they're asking me to solve for. So there's only one solution that I'm finding here. It's going to be pi over 2.